Hey guys, today we're going to start calculating the volume of prisms and cylinders. So a lot of this, if you know your area formulas really well from Chapter 10, this should be pretty straightforward. But if not, you're going to have some work to do with going back and kind of remembering how those formulas work. The other piece that's going to be really important is just being able to identify what a particular shape is, what the base is, so that you use the correct formula. So we're going to run through some vocab first, and then we'll get into a couple problems so you can see how this goes. Okay, so for volume. So the volume of a three-dimensional figure is the number of overlapping unit cubes of a given size that will exactly fill the interior. So again, when we're talking about volume, we're talking about kind of the amount of space to fill up a three-dimensional shape. Okay, so in other words, a cube built out of 27 little unit cubes, you probably use these unit cubes maybe in grade school, right, has a volume of 27 cubic units. So we're just talking about how much space we need to fill up when we're talking about volume. Now, we don't talk about this idea a lot, but it will come into play when we start doing problems, this Cavalieri's principle. All this is saying is that if two three-dimensional figures have the same height and they have the same cross-sectional area at every level, then they have the same volume. And here's what's really important for us. If we look at this shape here, this is what we call a right prism, right? Because it's standing upright. Kind of these faces are perpendicular to that base. So that would be called a right prism. Over here, when it's leaning, we call these oblique. And right now, the height of this one, we would actually have to drop down that perpendicular height for this one. So it would be kind of outside of that figure. But the idea is if they have the same area of the base, right, so we can see that they both have these triangular bases, and they both have the same height, whether it's right or oblique, they're going to have the same volume. So that's what it's saying here. A right prism and an oblique prism, and again, oblique just means it's kind of leaning over. If they have the same base and the same height, then they have the same volume. So that's why we don't have to worry too much about these oblique ones. We can find it the same way. Okay, so now we're going to talk about volume formulas now for prisms and cylinders. Okay, so when we're finding the volume of a prism, all we need to do, it says the volume of a prism with base area B. So the area of the base is B, and height H is just volume equals B, the area of the base, times the height. Right, so this is obviously very generic, and it leaves it open to finding a lot of different prisms. So this B is going to depend on the shape of the base. So if we have a triangular prism like we do here, to find the area of that base, we would use base times height. If we had some other shape, our area formula, or our B, would be different. So example, if we look over here, the volume of a rectangular prism is, we said it's V equals the area of the base times the height. Well, in this case, if I'm calling this the base here, the area of that base, instead of B, I'm going to substitute length times width, and then we multiply by the height. Right? So in this case, the area of that base is the length times the width. Similarly, if we look at a cube, right, we said volume, again, the generic formula is the area of the base times the height. Well, the area of this base, it's a square, so it's S squared. And then the height is times S, so that's how we get a volume of S cubed. But again, it's just all about taking this area of the base and subbing in the correct formula based on what shape that is. Okay, so now for the volume of a cylinder, if we have base area B again, okay, radius R, and height H, then we know that volume is still just the area of the base times the height. But in this case, we know the area of that base. For a cylinder, it's always going to be a circle, so that area is pi r squared, and then we multiply by the height. But again, it's because that capital B, that base, the area formula for the base is pi r squared. So really, these formulas are pretty generic, and we have to swap in the appropriate area of the base formula depending on the specific figure that we're looking at. All right, so let's go see what these problems would look like then. Okay, so we've got our targets here, so finding the volume of prisms and cylinders. We're also going to need to solve for a dimension of a prism or cylinder if we're given the volume. And I don't know why this is here twice. So we really have 2 learning targets here. Okay, now it says a note here, right? So the height, H, is always perpendicular to the base of a figure. Okay, so in a solid, right, whether that's a prism or a cylinder, when we're looking at these solids, we're thinking of the height as the perpendicular distance between the 2 bases. So sometimes that helps. If you can pick out the bases, then that height is just going to be that perpendicular distance between them. So for each of these problems, we're going to name the solid and then find the volume, and we're rounding to the nearest tenth. So for my first one, first thing I notice is it's going to be oblique, which is okay. It looks like my base here is going to be a rectangle. Since this guy does not come to a point, we're going to have a rectangular prism. Okay, so now we know our area formula is volume equals the area of the base times the height. And I'm just going to write there again that B is the area of the base. Now, for this one, our base, since we have a rectangle, the area of the base is just the base times the height. For this, that's 6 times 11. Now remember, the height, again, is only referring to this base figure. So 6 times 11 is 66. So now I know the area of my base of that prism is 66. I'm going to substitute it here. In my whole prism, the distance between those 2 bases is 14. So that's the height of my prism, and I'm going to substitute that here. So now I can find the volume of my figure. I have 66 times 14 is going to give me 924. Now, since we're doing volume, we're going to have cubic units. So I have 924 meters cubed. Okay, let's look at another one here. Now, we have a prism. I can tell because it's not coming to a single point. Now remember, to find those bases, I have to find the congruent and parallel shapes. And so I notice here that this guy is kind of on its side. There's one base, and here's another base here. So I'm going to have a triangular prism. Okay, so again, my formula is volume equals the area of the base times the height. Now, the area of my base, My base is a right triangle here, so I'm going to do 1/2 base times height. Now for this one, I actually have a little bit of work to do. I know that this leg of the right triangle is 4. From this side, I can tell that my hypotenuse is 5. But to get the base of that right triangle here, I'm going to have to use my Pythagorean theorem. Or, hopefully by now, we should recognize this would be a triple here, 3, 4, 5. So that leg is going to be 3. So now I can do 1/2. The base of my triangle is 3. The height of that triangle is 4. And so I have an area of my base of 6. So now that gets substituted up here, 6. The distance, the height of my prism is the distance between those two bases, which is this 6 here. So I'm going to multiply it by 6, and I get a volume of 36. And that's going to be 36 cubic kilometers. All right, so then the last one for this page, we're going to look at a cylinder. So hopefully we'll recognize that shape right away. Now for a cylinder, I just have it memorized that area is going to be pi r squared, right? The area of our base is a circle, so pi r squared times h. So I'm going to have pi times my radius is 4. I'm going to square that and then multiply it. Now, our bases here are these two circles. The height, we said, is the distance between those bases, which is the 12 that's right there. And since this said to round to the nearest tenth, I'm just going to put all of this in my calculator at once. And I get, let's see, to the 10th, 603.2 cubic centimeters. All right, so those are some basic volume problems. And again, you'll obviously be practicing with those in class tomorrow. So the next thing we're going to do for the rest of this video actually is work on going backwards. In other words, the problems will give you the volume and you need to solve for a dimension. So let's see what that would look like. So in this case, we have a trapezoidal prism. So I can see my base is this trapezoid here. Okay, and I'm trying to solve for this h, which is the distance between those two bases. So again, formula is volume equals the area of the base times the height. Right, so B, my base is a trapezoid. So I'm looking just at the trapezoid for right now. I know its area is h over 2 times B1 plus B2. Again, this h is just the height of my trapezoid. I'm not looking at this h yet. So if I look at my trapezoid, I'll notice that perpendicular height is 4.6. My one base of my trapezoid is 5. And then I actually have to look at my other base. Since that side is 9, this other base is 9 here. And I'm going to put that in my calculator to get the area of my trapezoid. Which I get is 32.2. So I know that's my B, the area of my base. We're trying to solve for the height, and we know that volume is 450.8. So now if I divide both sides by 32.2, I get my height is 14 inches. Okay, so the next one. Now we have a cylinder. They're giving us the volume and the height. So we need to solve for the diameter. So let's see. I know volume of a cylinder is pi r squared times h. So I'm going to plug in what I know. I know the volume is 180 pi. Please make sure to take that pi with you because it's actually going to simplify the problem quite a bit. We have pi times r squared, and we know the height is 5. So the first thing I'm going to do is cancel out the pi's, divide a pi from each side, and then I'm going to divide both sides by 5 to get rid of that height. So 180 divided by 5 is going to give me 36 is equal to r squared. So if I take the square root, again, I only want the positive radius because this is a distance, so that's going to give me 6. Now here's where I have to be a little careful. This is actually asking us for the diameter of that cylinder. So I know if the radius is 6, I actually need to double that, and I'm going to have a diameter of 12 centimeters. All right, last problem for today. We need to find the area of the base. So this is going to be really important. This is one that often gets missed because people actually try to do too much work. So we're trying to find the area of the base, which is just the capital B of a pentagonal prism with volume 84 cubic meters and height 7. So I know the volume of my prism is going to be the area of the base times the height. So the volume is given to me as 84. I'm trying to find the area of the base, and I know that height is 7. So all I need to do here is divide 84 by 7 to get 12. That's all we need to do. Now, in this case, because they're asking me for area, I know those units have to be squared. In the other cases, they were asking us for a diameter, a height, or something like that, so we had just regular units. But now if I'm being asked for an area, I need to make sure to give my answers in units squared. Okay, so that's it for today. We'll get practice to make sure we're really clear on how these work.